Right, here we're going to use some dominance matrices to be able to rank players in a tournament. You've worked with dominance matrices before earlier this year. This is a very simple example that we're working with, mainly to highlight that what we have found is in external exams, they are telling you what the weighting is in the second and first order influence so that you can just use it without having to make any assumptions regarding that. Okay, it says we want to seed 4 badminton players, Oliver, Benjamin, Brooke and Millicent. In past matches, Millicent defeated Oliver and Brooke. Both Oliver and Brooke defeated Benjamin. Benjamin defeated Millicent and Oliver defeated Brooke. By giving equal importance to first and second order influence, use dominance matrices to rank the players. So the first thing we're going to need to do is assign variables to each of these players. So let's give Oliver an A, Benjamin a B, Brooke a C, and Millicent a D. And so that means D defeated A and C, Oliver A and C defeated B, Benjamin defeated Millicent, so B defeated D, and A defeated C. It's probably a good idea to draw a diagraph to help us to understand this. So let's start with defining our variables. So let A equal Oliver, B is Benjamin, C is Brooke, and D is Millicent, and M will be my dominance matrix. And my vector we're going to be defining as the nth order dominance vector. Okay, doesn't like my handwriting today at all. All right. So let's have a look. Let's draw ourselves a diagraph and see what we can get out of that. Okay, so we have A, let's put B there, B, C, and D. And we know that A defeated both Benjamin and Brooke. Okay, so A defeated both B and C. All right. Brooke defeated Benjamin. No, Oliver and Brooke defeated Benjamin. Benjamin defeated Millicent. So B defeated D. Who did Millicent defeat? She defeated Oliver and Brooke. So D defeated Oliver and Brooke. And Brooke, who did Brooke defeat? Brooke only defeated Benjamin. Okay, so there's our little diagraph saying who defeated who. And we need to set up our matrix. I think I'm going to run out of space. I think I'm going to make this a little bit smaller so that I can set up my dominance matrix over here. Otherwise I am going to run out of space. All right, so we've got that M is equal to, and hopefully you remember that you're going to put your A, B, C, and D and A, B, C, and D on both of your headings for your rows and columns. And you hopefully also remember that a person can't be dominant over itself. So it means that you have the primary diagonal with all zeros. All right, now we just need to put in our whoever defeated whoever. So A defeated B and A defeated C. Who did B defeat? Well, B only defeated D, so it didn't defeat any of the others. How many did C defeat? Well, C only defeated B. And D defeated C and A and not B. All right. And my dominance vector, remember then what we need to do is sum each row to get our dominance vector, and that will be A, B, C, and D. So in my first row I have 2, 1, 1, and 2, and I can see that both Oliver and Millicent have the same rank, and Ben and Brooke have the same rank. So therefore Oliver and Millicent are ranked equally, as are Ben and Brooke. And we need to now figure out how to rank them. So we're going to use second order influence. So we're going to say, therefore, consider second order influence. And that's going to be our M squared matrix. So using my GDC, I'm going to find what my M squared is. And again, it's going to be using the same A, B, C, and D. And A, B, C, and D. And that one looks like this. And from that, I'm going to get my second dominance vector by summing my rows. Now, hopefully you remember from your previous PSMT that you don't use this vector. You need to add the two from, so your first order influence vector plus your second order influence one, and you need to assign importance to them. So what we have here is we've got 2, 1, 1, and 3. And I'm going to say, using equal importance, because that's what they told me to do. Usually our second order influence has less importance, but this one has said equal importance. I have V1 plus V2, which will be 2, 1, 1, 2. And the order of those matrices are the same, so I can add them. And that then gives me 4, 3, 2, and 5. All of those numbers are different, so I can rank them. Therefore, my ranking is Millicent. So our highest number is our first rank. Oliver, Ben,